Let's say we would like to predict the performance of an employee. This can be done in several ways. One of them is to predict whether an employee will be promoted or not. This is very easily done in Actable AI. First, we need to load a dataset using either a CSV file, an Excel file, or by connecting directly to a database. Once it's loaded, we can see its characteristics. So we can see the available columns, and we can also filter, for example, in this case by gender, to see only rows that we want to focus on. We can also view some statistics on the dataset, such as the overall distribution of each unique value, and also whether there are any missing fields. So in this case, for example, we might want to see if we need to cater for any class imbalance. For example, gender here is quite skewed towards males. We might also want to create some new features that might summarize certain aspects of our data more accurately, and hopefully they would improve the performance of our model. So there are two ways in which this can be done in Actable AI. The first is to use SQL Lab, as shown here. So we can just write our SQL queries. For example, here I have created two very simple columns, one of which computes the difference between the age and the length of service to determine when the employee started working at the company. And the second column um, determines if the employee has passed or failed a training program. So in this case, if the score is greater or equal to 50, the employee is said to have passed with a value of 1, otherwise they're assigned a value of 0 to indicate that they have failed. We can also create new columns by editing the dataset directly. So if we go to the dataset here, we can go to Edit, go to Calculated Columns, and here will be a list of columns that we have computed. In this case, we already made one. We can also create a new one by clicking on the plus sign. So we can give the name of the column here. Let's say we want to create the training pass column to determine if the employee has passed the training, and then we need to provide the SQL expression here. So we can go ahead and do that. When we are happy, we can also decide to fill in these features. These are the optional parameters, but they are not necessary, such as if the feature is temporal and the data type. Once we are happy, then we can go ahead and save. We will see then that a new row has been added with our new parameter. And if we go back to our dataset, we can verify that this new column has been added. So if we scroll here, we can see that the new column has been indeed added. Once we are happy with the columns that our dataset has, we can go ahead and train a model. So for this task to predict whether an employee will be promoted, we can use the classification task. We can then select our dataset and start to fill in the fields for classification. So first of all, we can choose if we have a time column, which will allow us to filter the number of rows according to the time range. In this case, we don't have one. We then select the predicted target. In our case, it's is promoted. The predictor, so try and which can be used to predict the target. In this case, we can just select all of them. We can choose if there are any sensitive columns that are protected against biases. We can choose if there are any extra columns to be displayed along with our results if they have not already been shown as part of the predicted target or the predictors. And then we can also use any filters to filter our data. We can also specify a training time limit to determine how long the model should train for. And then we also have some other options to specify how the model will be optimized. So the first one is to optimize for quality. So in this case, the model might train for a bit longer, but it will optimize the performance. Then we have explain predictions, where shapely values will be computed to determine the contribution of a feature onto the final result. Finally, we have cross-validation, which will allow us to more robustly assess our model. You can also use some advanced options, such as the metric to use for optimization, such as the area under the curve, and you can also specify feature pruning, which is very useful because it automatically discards any features that are not useful for performance or are even harming the performance. Once we are satisfied with our options, we can go ahead and run it. I have already computed a result, which we can see here. So in this case, first of all, we see that the positive label is assumed to be 1, and the probability threshold with which the results are computed is set to zero point 0.5. First, we can see the results of the performance of the metric. So the first metric is the one that we use for optimization. We use the area under the ROC curve with a value of 0.83, and there are also other metrics such as the accuracy with a value of 0.94 in this case. We also see here the receiver operating characteristics curve and the associated values of the x and y axes, and the precision recall curve with the probability threshold of zero point 0.5 indicated with this dashed line here. We might want to tune our model depending on certain requirements. So for example, we might want a higher recall than this. So if we go down the curve here, for example, with a recall of 0.6, we can see the corresponding value of precision and the corresponding value of the probability threshold that we need to achieve this sort of performance. Then we can see the predicted class versus the actual class. This is a confusion matrix to see how well the model has predicted the classes. Then we have a table summarizing the important features in our model. So this helps explain what features are useful. So in this case, we can see that the average training score is the most important one. So it makes sense that an employee with a higher training might get better chances at being promoted. The department also seems to be important, as is the previous year's rating, which also makes sense. Next, we have the dataset with the shapely values. So in this case, the shapely values, as mentioned, indicate the impact of that feature on the final result. So we can see here that we have three new columns. One of them is the predicted class, and the other two indicate the probability of each class. So how to interpret these shapely values? So for example, in this case it's green, it has a positive effect. So this starting age of 25 has increased the likelihood of the predicted class, which is 0 in this case. Similarly, if a value is shown in red, then that means that it has had a negative impact. It has decreased the probability of that class. We can also view other results. If we go to the leaderboard tab, we can see all of the models that have been trained, along with the corresponding scores, the training times, the hyperparameters, and the features that were used. This is particularly useful if feature pruning was selected. We can also see the original table, and we can also use a live model. So in this case, we can input new values for each of our columns, and then we can use the trained model, the best model, to get a prediction. We can also adjust the probability threshold and the positive label. Finally, we have the live API, which contains information on how to use the trained model on our own dataset. All of this information is documented in our documentation website on docs.ectable.ai. So we have all the information needed on what is classification, the parameters that are available, along with examples to help you see how results can be interpret it and how to best use the analytic. So that was it from my end. Thank you very much for watching this video. See you again in the next one.